let's open for this first presenter with the code of SEE-05. Pak Ahmad Jihad, Mr. Ahmad Jihad, he's going to present his paper, Effect Zinc, Copper, and Mangan Dropping on the Structural Characteristic of the Lithium Mangan Cobalt Oxide, NMC622. You have 10 minutes, Pak Ahmad. Go ahead.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
To share screen. Okay. Yes. Okay. Good morning, ladies and gentlemen. First, let me introduce myself. My name is Ahmad Jihad. I'm from Smart University. I want to take this opportunity to share my research about effect of zinc, copper, and magnesium dropping on the structural characteristic of NMC622. Lithium-ion battery are rechargeable battery that has numerous advantages. Nowadays, Li-ion battery have successfully utilized energy, storage, and power sources in electric vehicles, military space, and medical devices. The cathode is an essential component of Li-ion battery because it's fully responsible for the lithium-ion transfer process. NMC is one of the cathode with some advantages such as high capacity, high thermal stability, and low cost. However, it still has several limitations such as low electronic conductivity, severe capacity decay, and instability of nickel ions. One of the promising methods that can improve NMC shortcoming is by using metals as a doping element. In this paper, we performed doping on NMC622 material using zinc, copper, and magnesium as a dopant element with different composition and determining each characteristic doping sample using X-ray diffraction analysis. For the experimental, first synthesis of NMC precursor, nickel sulfate, mangan sulfate, and cobalt sulfate were dissolved using aqueous and stirred until homogeneous. Ammonia and the oxalic acid solution were added and stirred. The slurry was filtered and the precipitate is washed until reached natural pH. The residue was dried and ovened for 12 hours. This precipitate was labeled as an NMC precursor. Second, synthesis of zinc oxalate. Zinc sulfate solution was mixed with the oxalic acid solution, then the solution was aged and filtered. The precipitate is zinc oxalate and ready to use. Third, synthesis of copper 2 carbonate. Copper 2 sulfate solution was mixed with ammonium bicarbonate, then the solution was aged and filtered. The precipitate carbonate was ready to use. Fourth, synthesis of magnesium hydroxide. Magnesium sulfate solution was mixed with sodium hydroxide solution. Then the solution was aged for 24 hours and filtered. The precipitate was dried and magnesium hydroxide was ready to use. And the last is synthesis and characterization of NMC cathode. Lithium hydroxide from NMC and the doping material was added to the NMC precursor and then ground and mixed. The mixture was heated and furnace in the furnace and sintered under flowing oxygen. The mixture was crushed and the Xrd pattern of the sample was analyzed using X-ray diffractometer. Okay, this is for the result. For zinc oxalate, this is the result. And this is for magnesium hydroxide and copper 2 carbonate. And the characterization of each materials from the figure A, B, and D are suitable with previous Xrd pattern. Thus, we can conclude that the synthesis reaction was successfully performed. And for figure C can be attributed to the pure layer structure of NMC cathode material Xrd pattern from previous research. Thus, the reaction of this reaction was successfully employed. Next, for the Xrd analysis of doped NMC sample, as shown in the figure, it can be observed that almost all of the sample have an identical peak with pure NMC. The sharp peaks at 2 theta angle of 15 and 20 degrees and 40 to 40 degrees indicate that the NMC material has high NMC with copper content 5% and 10%. There is a new peak at 2 theta angles of 25 to 2 degrees, which indicates the presence of the copper oxide phase. Based on the figure, we can be concluded that the doping of magnesium and zinc were successfully conducted with no secondary phase detected, while the copper doping is successfully conducted when the concentration of the copper was less than 5%. This is for the lattice parameter analysis. The C per A value of the lattice parameter is a direct measurement of deviation of the lattice from the perfect cubic closed packed lattice. Since the ideal cubic closed packed lattice has C per A value of 4.899, the greater C per A ratio indicates a more ordered layered structure and the easier of the transfer of lithium ions. From this figure, we can conclude that not all of the sample have C per A value of more than 4.899. After the doping process, the NMC shows C per A values change. As we can look at the figure, the C per A can change toward dopant composition and types. Next, for the error coefficient analysis, the error coefficient is related to the hexagonal ordering of the materials. The lower R value shows the better hexagonal ordering of the materials. Error coefficient can be calculated using this equation. All of the sample have an error value of less than 0.45, which is indicated an excellent hexagonal ordering of the lattice. Next is I003 per I104 ratio analysis. To find out the inclination of cation mixing occurrence, we can the ratio of 003 peak and 104 peak. The higher ratio of this parameter leads to decreased cation mixing. Based on this figure, all of the sample have the possibility of cation mixing, but values for the lowest value of this parameter is for sample NMC copper with 10% analysis. It indicates that the sample has the strongest possibility of cation mixing than other samples. Okay, next for the crystal diameter analysis. Crystal diameter of all samples were measured using the Beer equation, and this is the equation. The biggest crystal size for the sample is NMC with 10% of magnesium composition, and the smallest crystal size is for the NMC sample with 3% of zinc doping. And the conclusion is the biggest C per A value was established at 3% of zinc doping. Magnesium doping with 1% composition in NMC material shows the lowest R value, and the smallest possibility of cation mixing than other sample is NMC with 3% of zinc composition. For the crystal size, the biggest crystal size is at 104 peak form when we introduce magnesium with 10% composition, and the smallest crystal size at 104 peak form when we introduce zinc with 3% composition. Okay, this paper is, I want to say thank you for your attention, and we hope this will be beneficial for you as it is for us. Thank you very much.
Thank you, Pak Ahmad, for the presentation. It is very interesting material of the presentation here about the battery. Now let's open for question and answer. Please, if there's any question, let me read here. There's a question from Bu Sylvia. What is the consideration in choosing doping material for lithium-ion battery, Pak? There's a question for you.
What is the consideration? Because zinc this doping has cheap and environmentally friendly. So we are choosing this doping for this NMC material.
The MNC, can you explain more? The MNC, those are including the lithium or not?
Of course, it is include the lithium.
Okay, so the question is that why do you choose the zinc? Why do you choose the copper and magnesium in doping? That was, I guess, the question.
Okay, I want to show the structure. This is the structure of my material. Okay. So from the previous research, why I choosing zinc, copper, and magnesium, because they are cheap, because the material is easy to get, and this material is environmentally friendly. So we use this. So we use this material as the doping of NMC 622.
Okay. Okay, thank you, Ahmad. Please, any other question? If you have any question, you can write down in the chat, or you can also say it directly in this presentation. While waiting, then maybe I should ask Pak Ahmad. There's some question that I have here. You mentioned about the Xrd analysis, Pak. That looks like for the content of the material purity, ya Pak. Ya. Just wondering what is the purpose of that, and how big is that machine? I just wondering if you can explain that machine to do the measurement for that. And another question from me is that do you have also the test with the voltage and current and the capacity that you have done using your new material, Pak?
Okay. For the electrochemical test, we will do it in the future because there's a time limit in my research. So it will be next. It will be next of my project. Okay, excuse me for the first question. Please repeat it. Pardon me. I can.
Yes.
I can understand.
The question. Yeah, you mentioned in your presentation there's a Xrd analysis that you mentioned with the graph, Xrd graph. Just wondering what is the purpose of that Xrd analysis, and how big is how does the measurement done by what tools?
For the measurement, we use Xrd diffractometer in our lab, and for the software, we are using an origin software to process the data. So there are So there are four. This is the data that I can conclude from that I can get from the Xrd analysis. This Xrd is actually a structural studies for affect the electrochemistry, but the electrochemistry we will do it in the future. For the Xrd, this is the result of the data that I processed. There are lattice parameter, air coefficient, I003 per I104 ratio analysis, and crystal diameter analysis.
Okay, thank you, Ahmad. There's another question here from Bu Evita. What will be the advantage to use zinc, copper, and magnesium in doping the MNC? That was the question in the chat.
What is my doping? Because the way I choose that dopant material, because from the previous research we can conclude that it can be in improving the structural characteristics of NMC material. So we are hoping for the future it will be next research that do more than dopant. Then I think try another methods like ferro or etc. I think that.
Okay, thank you, Ahmad. Is there any other question? We still have time. We have 3 more minutes. So while waiting then question, then Ahmad, I have some question here. Based on your graph here, you are trying to optimize the graph here. You want to have as high as possible crystal diameter, or what is the logic for this slide that you have, the figure 6?
What you call?
Yeah, what is the thing that you try to optimize on your graph? That looks like one of them is saying the size of the structure, etc. What can you explain?
Okay. For the optimization, I want to my target is high I0. The target is high I003 per I104 ratio analysis. After that, low air value, and my wish is this can be as low as possible for the air coefficient, and for the crystal is high as possible, as high as possible.
Okay. Can you explain why those are points that you are looking for?
For the air coefficient. In general, my purpose is to improving all of structural properties. So all of this experiment is to improving the structural properties of NMC 622. All of this. So if this has a great structural characteristic, it will be have a great capacity of the battery.
Okay, thank you, Pak Ahmad. I think the time is up. Thank you very much, Pak Ahmad, for your presentation. It's very interesting topic that you have